Hello all. This is a quick demonstration video to take you all through the Yang ACL implementation that we have done as part of the flow rule module for Netconf southbound plugin to the ON.OS SDN. As part of the ON.OS Netconf southbound plugin, we have uh, done two activities. One is the identification of the Netconf devices, and another is implementation of the Yang ACL model as part of the flow rule implementation. We'll quickly first go through the architecture of the southbound plugin. So this is a high-level architecture diagram. As you can see, the name suggests the Netconf plugin is the southbound plugin to the ON.OS core. We implemented two modules in it. One is the device identification, that is the Netconf device provider. This module identifies whether a device supports Netconf or not. It questions or queries the device about it, and based on the response it updates the ON.OS core about the Netconf support for the device. Another is the flow rule provider. As part of the flow rule provider, currently we have implemented Yang ACL model. Uh, we get the ACL parameters and the device details. We have a Yang to Java conversion at compile time. So Yang files are fed to that conversion utility, and we get Java objects as the output, which we use at runtime. We populate those with the ACL parameters and generate a message which we pass on to the devices using the JNC library. So this is a high level architecture diagram. We have a separate video for Netconf device provider, and hence we won't take it into detail in this video. In this video we will further concentrate on the flow rule provider part. We'll now go to the flow rule provider's flow diagram. So here, as I did a brief explanation before, we take the ACL parameters and the device details on which those parameters have to be implemented. We have a Yang to Java conversion utility which gives us the Java classes. At runtime, we populate those Java classes and create appropriate objects. We using an XML builder, we make the XML message which we pass on to the device using the JNC client library. One thing which I want to point out here is that currently we are reading the parameters using a flat config file. We have kept this kind of implementation so that we can implement the rest of the logic sooner, and also so that the overall solution is scalable to a northbound application where you can provide the necessary parameters using a northbound application, and you can then uh, bypass or don't need to use this approach of a flat config file. For our demonstration purpose, we have utilized confd. So as you can see, this is confd CLI, and we are showing the parameters for telnet block rule. As you can see, under telnet block rule, we have destination IPv4 address and source IPv4 address here. We will demonstrate a flow rule, pushing a Yang ACL flow rule to change these values. As we saw in the flow rule, we are currently providing the parameters to this flow rule provider through a config file. So we have a config file which resides in the etc folder of the Apache Karaf. So this is the config file which we used previously, and that's how you see the parameters on that the confd CLI are same. We have the same destination IPv4 address and the source IPv4 address as it was there. We will change these two parameters and again execute it. Now we have changed those two parameters and we are executing the flow rule. Yeah, as you can see here, after execution, the values have changed for destination IPv4 address and source IPv4 address. So previously we had the destination IPv4 address as 25.25.25.27, and instead of that we had changed it to the last octet to 25 as we did in our config file. That got applied here. Same for source IPv4 address, the last octet was 10, it is now 16, which also we had updated in our config file. We executed the flow rule and it has got updated in the confd. This is the confd CLI. This is the XML message which the flow rule implementation generated. As you can see, the IPv4 destination source IPs were changed here. This is the XML which was pushed to the device. Thank you very much.